Alright, I started a video on this and then the bell rang, so I stopped the video. But I'm not going to rewrite what I did already, I'm just going to explain. So when we're in free fall, this is a specific type of motion that you are only under the influence of gravity. Alright, there are two scenarios. One, where you have an object being dropped from some height. If you have an object being dropped from some height, your displacement is going to be negative. You're going from some higher position to some lower position, right, if this is ground level. Any object that's being dropped has an initial velocity of 0. And for all of our problems from now on, our acceleration is going to be your acceleration due to gravity, little g, and we're going to identify it as 9.81. So if we have a gravity acceleration of negative 9.81, we are in free fall. Right? Free fall is in the absence of air resistance. For an object being dropped, your velocity at any moment in time, aside from the initial, is going to be negative. We have a negative displacement. We're going to have a negative velocity here. And we're going to apply our kinematics to this situation. The second situation that you can encounter is when you have an object that starts at ground level and is being thrown up. So when you've got an object that starts at ground level, it has to have some initial velocity in the positive direction, right? My displacement is going up, 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 up. It's in a positive displacement, and my velocity is positive here. My acceleration, though, is still going to be negative 9.8. So since my acceleration is negative, my velocity is positive, they're working opposite each other, my object is going to slow down on the way up. Once it reaches highest point, the velocity is going to be 0. Right? When I'm at the highest point of tossed my ball up, at the highest point when my vertical displacement is the greatest, I will have a velocity of 0. Then the object, because it's under the influence of gravity, will fall back down to Earth. And on the way back down, it's going to speed up again. The velocity on the way down is going to be negative. Your acceleration due to gravity is negative. Since your acceleration and velocity are both in the same sign, negative, the ball is going to be speeding up. All right, so a few notes about when you throw something up and when it comes back down. So the velocity initial is going to be positive, and it's going to be equal to the velocity final, but the velocity final is going to be negative. So if you're given an initial velocity, say I throw this thing up at 5 meters per second, I'm going to catch it at negative 5 meters per second. Because on the way up, right, it's being influenced by gravity, and on the way down, it is still being influenced by gravity. So your displacement total is going to be 0 if I'm starting at ground level and I'm ending at ground level. Right, I'm not changing my position. When I'm at the highest point, so for these cases here, my displacement, I'm going to identify my displacement as y instead of x. Because my movement is in the vertical direction. So when I have the most height, y, I will have gone half my flight time. So it'll take the same amount of time to go up as it takes to come back down. We are going to do a few practice problems. We're going to use our kinematics on your equation sheet. All right, so those are our 4 kinematics. And you have these problems to do. I'm going to do a few with you. You guys are going to try the rest on your own. I'll try and pick a few of each kind here. Let's see. I guess we could do the first 3. I do want to make a note about number 5, though. Okay, so number 1 says Ant-Man drops a penny in a wishing well. It falls for 3 seconds before it hits the well. Hits the water. What is the velocity as it hits the water? So I have my penny. It's being dropped down the well, right? If this is my well and it's got water in it, right? My penny is being dropped down the well. Some of the information I've been given, it was dropped. So my initial velocity is 0 meters per second. My acceleration is going to be negative 9.8 meters per second squared. It fell for a time of 3 seconds. And it's asking you for its velocity after the 3 seconds. So because we have these 4 variables, I'm going to use the first kinematic equation. And it does not need to be rearranged because it already is isolated for V final. My V initial is 0. My acceleration is negative 9.8 times my time gives me negative 29.4 meters per second. All right, let's try number 2. A rock is dropped from the top of a cliff, so we're starting from a higher position and going to a lower position. And it strikes the ground 6.5 seconds later. How high is the cliff in meters? So my initial velocity is 0. My acceleration is negative 9.8. My time is 6.5 seconds, and I'm looking for my displacement, right? Or I'm